Hello again, higher algebra students, back with Unit 8, Lesson 5, which is factoring by brute force. So factoring with a not equal to 1 and just really more of a trial and error, guess and check model here. So by the end of this lesson, hoping that we can factor a quadratic polynomial with a not equal to 1 and be able to explain the process for guessing and checking the values to complete the factoring of a quadratic. So jumping in here, we have a polynomial with an a value that is not equal to 1 right here. 2x squared plus 7x minus 15. We're going to begin by determining the factors of both a and c. So not multiplying in this case like we did last time, but so what we have here is the factors of a would just be 1 and 2. The factors of c, so c is again a negative 15 here, so we'd have 1, 15, 3, and 5. So what we're going to do is really use these factors to consider the options for what we could have. So what I mean by that is for the a's, the a term or the first term in these factored problems could be a 2x or an x. And then the second term would be either a 1 and a 15. Again, then this would be a 15 and a 1 going the other way, or a 3 and a 5 and a 5 and a 3 going the other way. So what you can see here is it's all the different combos, 2x with 1 or 2x with 15. Is it x with 15 or is it x with 1, and so on. So all these options would make the a term a 2 and would make the c term a negative 15, provided one of them was a plus and one of them was a minus. So our next step is to determine which one gives us the b term that we need, which in this case is plus 7. So really what we're looking at is the o and the I in FOIL, keeping in mind the plus or minus as needed. So in this case, option 3, which would have an inside value of 3x and an outside value of 10x, again, we need the reason that ends up being of importance here is 10 and 3 have a difference of 7, which is what our b term is. So with that, we do need to recognize which one of these needs to be a negative. Well, we need a positive 10 and a negative 3. So when we have this 3, the 3 ends up getting the negative in front of it because the inside would then be negative 3 times x. The outside, being the positive value, again, would be the 2x times 5. So what you have to really think about is the 2 and the 5 then really have to be in different parts of the factoring terms, because we need to be able to multiply them through the O, in this case, of FOIL as the outsides being multiplied by each other. And again, what I mean by that is we never, multiply the 2 with the 3 here when they're in the same term. So keep that in mind as we progress through here. So on a problem like this here, looking at an example, we can see the factors of A would be 1 and 3, and the factors of C, again, C is just a 1 here, so the factors for C would just be a 1, okay? So what we know is that we are going to have, and everything's positive here, so we're going to have an x plus, and we're going to have a 3x plus, okay? Now, we need that the middle term to be 4, but again, because the factor of C is just 1, there really is actually only one option here, which is just x plus 1 and 3x plus 1. And again, if we were to FOIL this now, as we look at this, I'll change colors. First gives us 3x squared. Outside gives us plus 1x. Inside gives us plus 3x. And then last gives us the plus 1, which of course brings us right back to where we started. Okay, so there's a nice one to start with. Where that picks up a little bit is something like this. So things to notice here. In this case, there is a greatest common factor. So as we look at this, each of these have a 5 that goes into them, which allows us to make these numbers a little smaller at least. And so the first thing we'll do is we'll take this greatest common factor of 5 and we'll rewrite this. So we have 2x squared minus 5x minus 25. Okay? Now when we look at factors of A, we just have 1 and 2 rather than a 1 and a 10 and a 2 and a 5. So that limits the number of factors that we have, which is kind of nice. Again, We could factor out at the end as well. It's just going to be a little more difficult process because we'll have more factors, we'll be working with bigger numbers, and so on. Our factors of C then would be 1 and 25, and then the 5, 5 combo there. So in terms of our options, again, we could have a 1x, or just an x, with a 1, a 1x with a 25, a 2x with a 1, and a 2x with a 25. Okay, so the combos would be these two and these two there. Or we could do the 1x with a 5 and the 2x with a 5, and just have to look at what we'd have for a plus and a minus there. So looking at this, our B term needs to be a negative 25. So we need to look at this and say, okay, what two values here, or what scenario would leave us with a negative 25? But again, one of them's a plus and one of them's a minus. So for instance, if I were to choose this pairing, I would have either 1x plus 5, 2x minus 5, or I'd have 1x minus 5 and 2x plus 5. Okay, so that, again, that takes care, and again, there's this 5 out front that we don't want to forget about, but that's this 5. But when we look at this now, you can see the difference is where the plus and the minus goes here. So as we look at, for instance, foiling this first one, that gives us the 2x squared. Again, we're trying to match this now. And the last term gives us the minus 25. So again, what we're really looking at is what does the B term end up being here? And if we go outside, that gives us a minus 5x, and then inside gives us a positive 10x. So that's not going to work. That's only going to give us a positive 5x in the middle. And again, we needed a negative 5x in the middle. So we look at this again down here. That gives us a 2x squared. Outside gives us a plus 5x. Inside gives us a negative 10x. And last gives us a 25. So what we're seeing here, and again, just as a reminder, I think I maybe said earlier we want to get this to be negative 25. We want to get it to be negative 5 in the middle. And right here, that is a negative 5 in the middle. Now, why did this work out as it did? Because the negative 5 that's right here, this negative 5 got multiplied by the 2, which means the negative term was going to be more negative than the positive term was going to be positive. So what we looked at here was offsetting our negative term with the bigger x term, so with the 2x in this case, and that's what caused it to be negative. As you can see up here, the 2x was offset with the 5 for the inside and FOIL, and so that was going to lead to a positive 10x, whereas the outsides only led to a negative 5x. So again, looking at what combination of terms makes sense here. So our final answer would have a 5 up front and would be an x minus 5 and a 2x plus 5. So again, the plus and the minus, you're going to look at as trying to say, okay, if I want it more negative, then I'm going to put the minus away from my bigger x. If I want it more positive, then I'll put my minus away from the smaller x, as I did right here. And we'll continue looking at that if that seems a little confusing right now. So another example here, factors of A. In this case, we don't have anything 19's prime, so we can't factor anything out here. But our factors of A are now 1 and 6, and then 2 and 3. Our factors of C would be 1 and 15, and then 3 and 5. So as we look at our combos here, we could have a 1x and a 6x, a 1x and a 6x. I'll write them in a little different format this time. And those could be with a 1 and a 15, or a 15 and a 1, or it could be with a 3 and a 5, or a 5 and a 3, okay, in terms of what those get multiplied with. So there's really, if you look at this, there's two options here, 1x and a 1 and a 6x and a 15, or 1x with the 15 and 6x with the 1. And then the same thing here, there's two options on this one. And then, of course, if we change the 1 and the 6 to a 2x and a 3x, those could be with either a 1 or a 15 or a 15 or a 1, a 3 or a 5, or a 5 or a 3. So what we really have here are 8 different possibilities. What we do know is this time everything needs to be a plus. So what we have is looking at what combination here would give us the A and the C's that we need. So the 1 and the 6 and then the or the 2 and the 3, and then the 1 and the 15, or the 3 and the 5. But what area is going to add up to 19? And again, it's not just adding up like 1 plus 15, because you know that one of those is going to be multiplied by 6. So we see that we probably don't want to multiply the 6 by the 15, but if we multiply the 6 by the 1, so that would be, if we put a 6x and then a 15, a 1x, and then a 1, what that does is that ensures that the 1x, or the 1 is multiplied by 6 by putting the 1 opposite the 6x. That gives us 6x, and inside gives us 15x. Well, that's too many. That's 21x in the middle, okay? So what we're finding here is that this combination is not going to work, okay? Now, how about if we were to go with 1 times 3 here and 6 times 5? Well, 6x times 5 is going to give us 30x. 1x times 3 is going to give us 3x. Well, how about the other way? 1x times 5 is 5, and 6x times 3 is 18. Well, 5 and 18 is 23, so that's a problem. How about down here? 2x times 1 is 2. 3x times 15 is 45. That's way too many. 2x times 15 is 30. Uh-oh, that's going to be too many. 3x times 1 is 3, so that's 33. So these combinations don't work. How about here? 2x times 3 is 6x. Sorry, this is a 3. 3x times 5 is 15. So 6 and 15 is 21. Again, that's not going to work. But a 2x opposite of 5 is 10, and a 3x opposite of 3 is 9, and 10 plus 9 would be 19. So what we mean by that here is, as I take that idea out, I would have a 2x that's opposite of 5 here. So that means the 5 would be over here, and then the 3x would be opposite the 3. So now when we do outside and inside, we have 10x on the outside, 9x on the inside, so there's our 19. Again, when we figure out what multiplied here, as we did right here and here, that doesn't mean they go in the same term, that means they go in opposite terms, so that when we FOIL, they get multiplied together. So our answer here ends up being 2x plus 3 and 3x plus 5, and again, the 2x times the 3x for the first is 6x squared, and the 3 times the 5 at the end is 15. And we already checked the B term as being 19, so we're good to go there. Okay, continuing on. Here we have a -5 again, so we need a positive and a negative. So it's going to be, in this case, 3x plus or minus something, and then x plus or minus something. And the reason we know it's going to be 3x and x is because the factors of A are just 1 and 3. The factors of C are just 1 and 5. So this is really nice. So what we know is it's going to be 3x and 1x, and it's going to be 1 or 5 or 5 or 1. And we know that 1 needs to be a plus and 1 needs to be a minus. So for instance, if we did, in this case, 3x times a -5, that'd be -15. And this one, 1x times a 1 would only be 1, so that would be -14, so that would be a problem. If we do 3x times 1, that's 3x, and 1x times 5, that's 5. Well, if we make one of those a negative, because we'd have a 3x and a 5x, if we make one of those a negative, we can get to a -2x, so we know that this one needs to be a negative. So, again, what we did here is 3x times 1 and 1x times 5, but we need the 1x times 5 to be a negative, so that means that we would need the one with the 5 to be the negative, but we need it to be opposite the 1x, so it would be 3x minus 5 and x plus 1, and what that guarantees again then is that we get the 1x times the 5 to be a negative, which is the inside term in FOIL here. The outside term in FOIL is going to be 3x times 1, so that's just a positive 3x. The inside term is a negative 5x, so there's your negative 2x. So that becomes the final answer in this particular problem. Continuing on, just to see some more here, factors of A here would be 1 and 6 and 2 and 3. Factors of C would just be 1 and 2. And again, we now have a B value of negative 1. So as we look here, we could have 1 and 6 or 2 and 3. And again, they're going to be multiplied by 1 or 2 in each of those. Oh, this is a 1 here. So for instance, 1 times 1 is 1. 6 times 2 is 12. That's going to be tough to get to be a negative 1, even if we make one of them negative. 1 times 2 is 2. 6 times 1 is 6. 2 and 6 are, even if we make one of them negative, the difference would be 4 there, so it would be a negative 4. So that's not going to work. Going down here, 2 times 1 is 2. 3 times 2 is 6. So 2 and 6, again, have a difference of 4, so that's not going to work. 2 times 2 is 4. 3 times 1 is 3. So there's our combination. So we need the 2x to be opposite the 2, and we need the 3x to be opposite the 1. Again, that's what's going to make the 3 multiply by the 1 and the 2 multiply by the 2. So we know that it looks like this. Now, what needs to be negative? Is it the 3x that needs to be negative on the inside, or the 4x that needs to be negative on the outside? Well, it's a negative 1, so we need the 4x to be the negative, so we would put the negative in front of the 2 there, so that this is a negative 4x. We'd put a positive in front of the 1, so this is a positive 1x. Excuse me, positive 3x. And so that would combine to be a negative 1x for the B term there. So in the end, there is our final answer. All right. Continuing on, just a couple examples here of factoring by brute force versus factoring by grouping. And so when we look at factoring by brute force here, the factors of A are 1 and 7. The factors of C here would be 1 and 12, 2 and 6, 3 and 4. Okay, so we've got a lot of combinations here. So we could do a 1 and a 7 with a 1-12 combo. We could do a 1 and a 7 with a 2-6 combo. Or we could do a 1 and a 7 with a 3-4 combo. Okay, and we need it to equal 40. So we do need to blow this number up a little bit. And so as you look at this, it is a negative 12. So we know we're going to need we need one of these to be a minus. Okay, so it's going to be 7x plus or minus, and then x plus or minus. Okay, so when we look at that, 1 times 1 is 1, 7 times 12 is 84. That's going to be way too high, even if one of them's a negative. Difference of 83 there. 1 times 12 and 7 times 1, well, that's only a difference of 5. We go to the second one here. 1 times 2 is 2. 7 times 6 is 42. All right, so there's our combo. So we need the 7 to be multiplied by a 6. So the 6 is going to have to go over here, so the 7 gets multiplied by it, which means the 2 is going to go here, and so that just the x gets multiplied by it, the 1x. Okay, so that means our inside is 2x of some sort, and our outside is 42x of some sort. But again, we need one of those to be negative. Well, what we need to be negative is the 2x, because we need this to be a positive 40 overall. So we need that to be negative, which means that subtraction is going to be over here. The addition is going to be over here. So again, our answer here would be 7x minus 2 and then x plus 6. Now, if we did this by grouping over on the right side, again, the process for grouping here is to get a times c, which in this case is actually 7 times negative 12 or negative 84. So what we need to do with that negative 84 is look at what are the factors of negative 84, which would be 1 and 84, or one of those is negative. 2 and 42. Well, the 2 and 42 is already a bit of a telltale sign for us. We could use 4 and 21, and so on. But what we know here is that 2 and 42, if we make one of them negative, we can get them to add up to 40, which is, again, the goal of grouping, because then we can rewrite this as 7x squared. And we could do either plus 42 or minus 2 next. I'll just do the minus 2. X plus 42x. Sorry, I'll rewrite that. 42x minus 12. And again, now when I write this as a group, here, two groups, I would have 7x squared minus 2x plus, I always put the plus in the middle, 42x minus 12. So to factor out of the first one here, 7 is prime, so I can't factor out a number, but I can factor out an x. So that gives me 7x minus 2, which means I'm hoping this can be 7x minus 2. And to pull out of there, to make that 7x minus 2, I need to pull out a 6. So now I have 7x minus 2 here, and then what's left is an x plus 6. And you can see those two answers are the same. Do just a couple more of these if you want to see it again. On this particular problem, you can see that we do have a factor situation. With 8 and 12, we could factor a 4 out of this if we want to right away. I'm going to show this actually as though we didn't recognize this right away. So let's do this as though we didn't see that we could factor out a 4. So my factors for A are 1 and 8 and 2 and 4. My factors for C are 1 and 8 and 2 and 4. So again, my combinations are to have A be 1 and 8, and then C is either 1 and 8 or 8, 1. I could have it be 1 and 8 and then 2, 4 or 4, 2. I could have it be 2, 4 with a 1 and 8 or 8 and 1. And then finally 2, 4 with another 2, 4. So you can see, had we factored out right away, we would have really limited the number of options here. But now we have really 2 options to check with each one of these. I'll keep it there. And so there's really 8 options to check here, but we need a positive 12. So as we go through here, what could lead us to a positive 12? Well, this is 1 times 1 and 8 times 8. That's going to be way too high. 1 times 8 and 8 times 1, well, that's 16. But again, it's the difference that we need here, since this is a negative 8 for the C. So we need something that has a difference of 12. Let's see, 2 and 32, nope. 4 and 16. 4 and 16 has a difference of 12. So if we look at this, 4 and 16, we could write this. Again, 8 would need to be opposite the 2, which means the 1 would be opposite the 4. And again, this would be, the inside would be 4x, the outside would be 16x. We need it to be a positive 12, so that would mean the 4 is the negative term here. So we have to put a negative in front of the 4. Oh, sorry about that. A negative here and a plus here. Now, because we didn't factor to begin with, our last step is to actually factor a 4 out of the first term. So this would be 2x minus 1 and x plus 2. The second term doesn't have anything factored out, but we'd factor a 4 out of that first term. Since 4 times 2x is 8x, 4 times negative 1 is negative 4 there. So our final answer, again, would be this terms in the black here for our factoring. Now, factoring by grouping, again, if we didn't factor out the 4 right away, what we'd have is AC would have a negative 64 value, 8 times negative 8, which means our factors of 64 would be 1 and 64, 2 and 32. Let's see, what do we have? 8 and 8, we know. 4 and 16, we know. And again, we need them to have a difference of 12. Oops, this should be a plus 12 here. Sorry about that. We need them to have a difference of positive 12 here. And so what we're going to use is the 4 and 16 because those two have a difference of 12. So we're going to rewrite this as 8x squared. And again, I'll put the plus first this time. So it would be plus 16x minus 4x. Again, I'm making the 16 the plus because the difference needs to be positive 12. And again, that was my fault right out of the gate there, having it as a negative at first. So that would be our term, our rewritten for the grouping. So now we would have 8x squared plus 16x, always have a plus, then this would be negative 4x minus 8. So what we could factor out of the first term is a full 8x here, which would leave us with x plus 2. Okay. Now, out of our second term, if we wanted to get an x plus 2, what we would need to factor out then here is a negative 4. Okay, and again, we'll just put a plus sign there. So if we factor out a negative 4 times x is negative 4x, negative 4 times 2 is negative 8. So that leaves us with x plus 2 and then 8x minus 4, which again is what we had right here. So we're going to factor out, we'll keep the x plus 2, but we're going to factor a 4 out of this second term. And so we can just rewrite that if we want to as 2x minus 1, and then x plus 2. I'm just kind of reversing the order here. So it leads to the same answer. Again, whether you factored out at the beginning or the end, it would not change your answer. Final example here. Just one last shot to look at it if you want to. What we see here is we can't factor anything out because 19 is prime. But we do have, by brute force, we have that the factors of A would be 1 and 10 or 2 and 5. The factors of C would be 1 and 6 or 2 and 3. So you can see again, we're going to have a lot of options to look at. Because each one of these combos, so the A being 1 or 10 could go with a C of 1 or 6. The A being 1 or 10 could go with a C of 2 or 3. The A being 2 and 5 could go with a C of 1 or 6. And the A being 2 and 5 could go with a C of 2 or 3. But we need now the product to be positive, and we need the sum to be negative. So this is going to be one of those situations where we have two negative numbers. So we're going to end up with something minus and something minus. So that we have a negative times a negative to get a positive, but the two negative numbers to add up. So we need to figure out where are we going to get a negative 19. So 1 and 1 is 1, 10 and 6 is 60. Well, that's not going to end up being negative 19. 1 and 6 is 6, 10 and 1 is 10, 10 and 6 is 16. That's just not enough. 1 and 2 is 2, 10 and 3 is 30. No, that's not going to work. 10 and 2 is 20. 1 and 3 is 3, so that's 23. Again, they're both going to be negative, so that'd be negative 23. 2 and 1 is 2. 5 and 6 is 30, so that'd be negative 32. 2 and 6 is 12. 5 and 1 is 5, so that'd be, if they were both negative, that'd be negative 17. So that's not going to work. So we've ruled out all of these. So we do know that this is going to be a 2x and a 5x. So let's see. 2 times 2 is 4. 5 times 3 is 15. Well, that's exactly what we need, is 4 and 15, because those two, if they're both negative, add up to negative 19. And we need the 5 to be opposite the 3, so that would mean this is the case, because there's our negative 15x, and the 2 to be opposite the 2, so that we can multiply those to be our negative 4x, and there's our answer. And again, if we were to group this, we would figure out that AC is 60. So again, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. We have all these combos, but again, we need them both to be negative and to add up to 19. So there's your 4 and 15 combo. So we're going to rewrite this as 10x squared minus 4x minus 15x plus 6. Again, these all needed to be negative numbers here because it's a negative times a negative. So what 2, if they're both negative, would add up to negative 19? And that's why we picked this one here. So as we group this, we've got 10x squared minus 4x, always put the plus, negative 15x plus 6. And again, always putting the plus is just about making your life a little easier in terms of remembering where to carry operations through parentheses. So that's the only reason there. It's not something you have to do. It's just, it makes it a little easier to deal with. So out of our first term, we can pull a 2x because 2x goes into both of these. That leaves a 5x there. So 2x times 5x is 10x squared, which is what we needed to be, minus 2. Again, because 2x times negative 2 would give us the negative 4x there. And so this one we also hope to be 5x minus 2. And what do we need to take out of there? Well, it needed to be a negative 15 for the first term and a positive 6 for the second. So that's going to be a negative 3. So that negative 3 times 5x is negative 15x. And negative 3 times negative 2 is positive 6. And again, we need those two to be the same. That's the whole idea of why we knew that needed to be 5x minus 2. And then the other term, which would be here and here, would then just be the 2x minus 3. So there is our answer. And again, that answer matches what we had up here. They're just in different orders there. So thank you as always for listening. If you have questions, please feel free to ask.